Moving on to our next topic, that is LSB methods or the least significant bit method. In general, the 8th bit is known as the least significant bit. Now, when using a 24-bit image, a bit of each of the red, green, and blue color components can be used, since they are each represented by a byte. In other words, one can store 3 bits in each pixel. An 800 into 600 pixel image can thus store a total amount of 14,40,000 bits or 1,80,000 bytes of embedded data. In its simplest form, LSB makes use of BMP images since they are lossless compression. Now moving on to the example of image steganography. As you can see, a grid for 3 pixels of a 24-bit image can be as follows. You can see the binary representation of the image. Now when the number 200, which binary representation is 1100 is embedded into the least significant of this part of the image, the resulting grid is as follows. You can see the bold number 110 as a change bit. Now when you change this, the original image and stego image remains the same, as they are not visible to a human eye. Moving on to next, that is audio steganography. Hiding secret data in the audio format or a digital sound is known as audio steganography. Now the supported formats for audio steganography is WAV, AU and MP3. Now few techniques for audio steganography are LSB coding, phase coding, parity coding and spread spectrum. Now the flowchart of audio steganography. First we select a WAV file as a carrier and a text message. Then we open a carrier file and prepare a message text as a binary column vector of 8. Then we skip the first 44 bytes of the carrier, which is address part of the WAV file. Now we prepare rest bytes of the carrier as the matrix of 8 columns. Now we replace the least significant bit of a carrier matrix with corresponding element of a message vector, and as an output we get a stego file. Now the example of LSB method for a sound. The message hi is encoded in a 16-bit CD quality sample using the LSB method. Here the secret information is hi and the cover file is audio file. Hi is to be embedded inside the audio file. First the secret information hi and the audio files are converted into a bit stream. The significant column for the audio file is replaced by the bit stream of secret information hi. The resulting file after embedding the secret information hi is called a stego file. Now you can see this on your screen as an example. Now what are the applications of this? This is confidential communication and secret data storing. Steganography provides us with potential capability to hide the existence of confidential data, hardness of detecting the data, strengthening of the secrecy of the encrypted data, protection of data alteration, access control system for a digital content distribution, usage in a modern printers. Now, what are the steganography tools? The steganography tools include Steganos, S tools for GIF and JPEG, StegHide for the WAV BMP files, Invisible Secrets for JPEG file, JPHide, Camouflage, and Hidden. Now let us see what are the future scopes. It is a fairly new idea. This continuous progress in the computer field, suggesting development in the field of steganography as well. It is likely that there will be soon more advanced technique in this field. A positive advancement is the improved sensitivity of small message. Knowing it is hard to detect the presence of a fairly large text file within an image, imagine how difficult it is to detect even one or two sentences embedded in an image. It is like finding a microscopic needle in the ultimate haystack. Now the conclusion for all this steganography is the developing stage of the development. The importance of steganography has not been yet noticed, so that the stage where it gets selected over its close rival, encryption. New techniques are being identified and implemented. It is considered that time is not far away when its importance would be realized by organizations in general and armed forces in particular. So that's all for the steganography. Thank you and have a very nice day.